What's up, Internet? Today we're going to talk about function notation and linear functions. To tell you the truth, I think we've already done this already, but it's important enough to do it again. But it's real simple, so I'm going to go kind of fast. Now, function notation is f of x. This is called f of x. Now, f of x is the same thing as y. Remember y equals mx plus b? Well, we're going to have f of x equals mx plus b, but it means the same stupid thing. So let's let f of x equals 3x minus 5. And you're going to see this on the final exam, and it will say find the value of x equals 4. Real simple. If x is 4, 4 is x, blah, blah, blah. So what we want is f of 4 equals, in other words, wherever there's an x, we're going to plug in 4. So it's 3 times 4 minus 5, which is 12 minus 5, which I think is 7. Actually, you can put these in the calculator just like that, and it will spit out the answer. It will do order of operation for you, because this is nothing more than order of operation. Now, the ordered pair, so if f of 4 equals 7, remember f of x is y, so y equals 7, and x is 4, right? X is 4. So our ordered pair on the graph would be 4, 7. Remember, they're always in the form xy. Okay? Okay. Now, they get longer. They really don't get any more difficult. So if we have f of x equals negative x squared, if you're going to put this in the calculator, remember when the negative is at the beginning, you use that negative key that's like that. This one down here. Negative x squared plus 5x minus 3. Find the value of f of 4. So wherever there's an x, we're going to plug in 4. So we have negative 4 squared plus 5 times 4 minus 3. Now remember order of operation. It's going to do, remember this is actually saying subtract 4 squared. So we have, this is actually would be in parentheses. So we have negative, bring that down, 16 plus 20 minus 3 is, let's see, that's 4 minus 3, what is that, 1? Okay, now remember, this is the same thing as y. So f of x, x is 4, so we have the ordered pair 4, 1. And that would be, you graph it over 4, up 1 would be roughly there. Okay, about as difficult as these get is like this. If you have g of x, remember g of x is the same thing as f of x, it's just a different notation for a different function. So if g of x equals 2x plus 3, find g of x equals a plus 1, or g of a plus 1. bonehead. Find g of a plus 1. So wherever there's an x, okay, x is this. This is x. Wherever there's an x, we're going to plug in a plus 1. So 2 times a plus 1 plus 3. We have distributive property here. It's going to be 2a plus 2, right? Multiply 2 times everything in here. Plus 3 is 2a, what is it, 5? Plus 5. And that's basically all there is to this function notation. It's actually very, very simple, and you can use your calculator to do it. But don't tell Dr. Ford I said that. Okay, solving quadratics. Okay, solving quadratics. Now, quadratic equations are always in the form ax squared plus bx plus c equals 0. I always set it to 0. And a cannot equal 0, and a, b, and c are real numbers, no imaginary numbers. Okay? So, let me back up just a second. If x squared equals 16, in other words, this number times itself is 16, what can x be? X could be 4, right? Because 4 times 4 is 16. And x can be negative 4, because negative 4 times negative 4 is also 16. Okay, so if you're given that x squared plus 4x plus 3 equals 0, what we're going to do is, first of all, we're going to factor this into x plus 3 times x plus 1 equals 0. So what we're going to do is we're going to take each one of these factors and set them equal to 0. X plus 3 equals 0, and x plus 1 equals 0. Subtract 3 from each side. X equals negative 3, and here x is negative 1. Subtract 1 from each side. Okay, so either one of those you can plug back into this the original equation, and it will come out to equal 0. Therefore, remember the 3 little dots in a triangle mean therefore, the solution set equals negative 3 comma negative 1. Do this in ascending order, the smallest number first. Okay, now what if we have this? A squared equals 9. Now, what we can do is subtract 9 from each side, and you get a squared minus 9 equals 0. What do we have here? A conjugate, right? It's a plus 3 times a minus 3 equals 0. Set each one of these equal to 0. A plus 3 equals 0, and a minus 3 equals 0. So we subtract 3 from each side, and we get a equals negative 3. Here we're going to add 3 to each side. A equals 3. Right? Right. Now, if you put this in the calculator, and remember, we don't use a, we use the variable x, which is up here, x, and the squared is here, minus 9. Okay, look and make sure you entered it right. Go to the graph, and if you'll look, it's going to go through -3 and +3. Right? Right. Okay, now we can also look at it like this. If a squared is 9, how do we undo a square? Square root, right? So we can square root this side, square root this side. So a equals, remember the square root of a squared is a, equals what? What is the square root of 9? Remember, square root means what number times itself is 9, plus or minus 3, which is exactly what we got up here. Okay, we're going to use this more here directly. Okay, what about this? What, excuse me. What if we have b squared equals 25? Same thing. We're going to take the square root of everything in there. So b is going to equal plus or minus 5. Because remember, 5 times 5 is 25. And -5 times -5 is also 25. Now, what if we have this? C squared equals 7. 7 is a prime number, not available for factoring. So how do we undo this? Of course, it's square root. So we have C equals plus or minus the square root of 7. Right? Right. What could be more fun? Now, at this point, get yourself a Diet Coke and take a slug. Mm-hmm. Mm-hmm. Okay. 5m squared minus 40. 5m squared minus 40 equals 0. Now remember, we're going to get rid of the addition subtraction first. So we're going to add 40 to each side. 5m squared equals 40. Divide everything by 5. M squared equals, what is it, 8? Something like that. Right? Right. Now, so we take the square root. So m equals plus or minus the square root of 8. Now 8 we can factor. What are the factors of 8? Well, one of them is a perfect square. This equals plus or minus the square root of 4 times 2. Right? This equals, the square root of 4 is 2, plus or minus 2 times the square root of 2, which you can write as 2 times the square root of 2 and -2 square root 2. And all that equals m. Right? Right. Okay. What about this? This is about as difficult as they get, and that's really not all that hard. How about this? X minus 3 all squared equals 16. Okay? Square root, square root. Remember, when you take the square root of a square, it just takes out the square. So we get x minus 3 equals plus or minus 4. Right? Right. So we have two possibilities. We have x minus 3 equals 4 and x minus 3 equals -4. So So we're going to add 3 to each side here and here. So x will equal 7. Add 3 to each side, and x equals -1. Okay. To be more fun. Okay, what about this one? Kind of the same problem. X minus 3 all squared equals 5. 5 is a prime number, cannot be factored into anything other than 1 and 5. So we take the square root of everything, and that equals x minus 3 equals plus or minus the square root of 5. I guess I should have put that under a different radical. Plus or minus the square root of 5. So we have x minus 3 equals the square root of 5, and x minus 3 equals negative square root of 5. Now we're going to add 3 to each side. Here we have x equals 3 plus the square root of 5. Again, add 3 to each side. And we get x equals 3 minus square root of 5. Okay. Okay, now this problem, 3r minus 2 all squared equals 27. So how do we undo the square? Square root. So we get this. 3r minus 2 equals plus or minus. Now we can factor 27 into 1 as a perfect square. 9 times 3, right? So we have 3r minus 2 equals, we take this out, plus or minus 3 times the square root of 3, right? So we have 3r minus 2 equals 3 times the square root of 3, and 3r minus 2 equals -3 square root of 3. And we're going to add 2 to each side. Same thing here. So we get 3r equals 2 plus 3 times the square root of 3. Now, can we add the 2 and the 3 here? No, because this is 3 times this. If it was 3 plus this, then we could. Same thing here. 3r equals 2 minus 3 square root 3. Now we're going to divide everything by 3. So we get r equals 2 plus 3 square root 3 over 3, and r equals 2 minus 3 square root 3 over 3. Well, a lot of 3's in that one. Okay, can we reduce anything here? Can we reduce this 3 and this 3? No. If this was multiplication, we could, but this is not. So these are two separate terms. Okay. Now, okay, I know we've done this, but we'll do it again just for fun. Okay, I know we've completed the square before when we were doing circles, But this is a little bit different, but so completing the square is the same process. It's exactly the same. First of all, we're going to move the constant to the other side. So we're going to add 7 to each side. We get x squared plus 10x. We're going to skip a little space to complete the square, equals 11. Now remember, we take half of this and square it. Half of 10 is 5, and 5 squared is 25. Now we added 25 to this side, so we have to add 25 to this side. So we get this. Now this is a perfect square because we made it one. It's x plus 5 all squared. Hold on. That was my little kitty. Okay. Now, this is a perfect square. Okay, it's x plus 5 all squared equals 11, and 25 is 36. So we take the square root. So now we get x plus 5, the square is gone, equals plus or minus 6. Right? So we have two possibilities here. We have x plus 5 equals 6, and x plus 5 equals negative 6. Subtract 5 from each side. Same thing here. So we get x equals 6 minus 5. I think it's 1. And here this is x equals negative 11. Okay? It's the same stupid problem we were doing with the circles to find the center and the radius. The only difference is here we're going to solve, set them equal to 0 and like that. Okay, last thing, I think. I don't know about you, but I'm hating on the quadratic equation. Hang on. Okay, the quadratic equation is this. I know it looks horrible, and to tell you the truth, I've never much cared for this, but it's here, so we have to do it. Okay, x, in other words, to find what x is, you do negative b plus or minus b squared, blah, 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 blah. Now, quadratic equations are always in this form, so if we have this, if we have 6x squared minus 5x minus 4 equals 0, okay? Our a is 6, our b is negative 5, and c is negative 4. So we're just going to plug these numbers into here. So we get negative b, negative 5. Because remember, the formula says negative b. So negative 5 plus or minus the square root of b squared. Now b is negative 5 squared minus 4 times a is 6, times c is negative 4. All over 2a, 2 times 6. Okay, let's clean this up. Negative 5. Can you be more stupid? Okay. Negative 5 is a positive 5, plus or minus the square root of negative 5 squared is 25. Minus 4 times 6 is negative 24. And a negative 24 times negative 4 is going to be a positive 96, I think, over 12. Right. So this is going to equal, I'm going to bring this down here. 5 plus the square root of 121 over 12. Now the square root of 124 is 11. So we have 5 plus or minus 11 over 12. And so 5 plus 11 over 12 and 5 minus 11 over 12. Of course, this is 16 over 12, and what is that, a negative 6 over 12. Now 16 over 12 can be reduced. Both of these are divisible by 4, so that's 4/3 and a negative 1/2. I'll do a couple more of these in class because I'm running out of time here on my. One more thing. Where is quadratic equation? Oh, here it is. This part right here under the radical, this is called the discriminant. D-I-S-C. The discriminant. Okay, here's the quadratic equation again. Now this part right here, the part that's under the radical, this part right here, is the discriminant. Now what that tells you is if the discriminant the numbers under the radical is called the discriminant. This is not super whiz-bang important, but you may see this. So if the discriminant is positive, greater than 0, you'll have 2 solutions. If it's negative, there will be no solutions. If it's equal to 0, there'll be 1 solution. If it's positive, but not a perfect square, it will have 2 irrational solutions. Again, not super whiz-bang important, but you may see this from time to time. Okay, that's all. Bye-bye. Bye, bonds.